Talk about probability a little bit. Probability, by that definition, I guess, wise, probability is the likelihood of an event occurring. Likelihood of an event occurring. I like to begin on probability talking about just say we flip a coin and I ask you what the probability of getting tails is. What would you say? What would you answer to that? What is the probability of getting tails? Flip a coin. What would you say? Huh? 50%? Okay. Is anybody else thinking something different? 1 in 2 chance? Okay. Yeah, there's probability can come in different forms, and these are two perfectly legitimate forms. Some others I've had, 50-50. What's the probability? It's 50-50, which obviously goes hand in hand there with 50%. 1 in 2 chance, 1 out of 2. Different ways you can state probability. Now, the way most often that we'll list probability, especially here at the beginning, is as a fraction. So if I were going to ask you what fraction you would say the probability of getting tails is, what would you say? What's the fraction? 1/2? Yeah. So here's kind of a notation. P parentheses tails, probability of tails. So you see P and then parentheses with something in it. That's going to be our notation for the book's notation for probability. So this just means the probability of tails in this scenario here is, like I said, equals. The most common one we'll see beginning anyway is as a fraction. And in this case it'd be 1/2, which of course is very, very much the same as having this, right? 1 in 2 chance, and we'll kind of go through that in a second, but we've got 1 and 2, right? Same thing as that. Now, how is this related to 50%? Well, if you take this and turn it into a decimal, 1 divided by 2 is, punch that on a calculator, you get 0.5, don't you? So as a decimal, it would be 0.5, and then change that over to percent. Remember, we move it 2 places over, and so that would make it 50%. Okay, so these all three are related. Fraction, decimal, percent. They all go hand in hand. And sometimes we list probabilities in those 3 different ways, depending on the problem or what you want. Okay? But yeah, now what? Let's kind of deconstruct this. Why is it 1 out of 2 or 1 in 2 chance? What's the 1? Or what does the 2 mean? Let's start with the 2. Why is this number 2 here, do you think? There's 2. Okay, there's two possibilities, right? When you flip a coin, you've got heads or tails. So you've got 2 possibilities, and one of them is the tails, right? Okay, so that's basically the definition, if you want a definition of probability. What you do is you take, the tails here, we could say it's the successes. In this case, the heads is the one that is not the success here, but the 1 tails is the number of successes or favorable outcomes, and then the two possibilities, that's the number of total possibilities there are. Okay, so that's probability-wise. Let's say you just do the probability of events, call it E. Find this way. Probability of E is you take the number of successes there are, because there's liable to be more than one. In that case, there was just one. You take the number of successes, also we'll call them favorable outcomes, is you take that number and you divide it by what? The total number of possibilities there are. So probability is always a fraction like that. Okay? So what we want to look at is just, let me also mention one other thing. Back when we were flipping the coin, well, let me just tell you that another definition, I'll do that specifically for the flipping the coin. Sample space is another kind of definition. A sample space is just a listing of all the outcomes possible. And that's, of course, tied in to the number of possibilities. Yeah, so if I asked you then for the sample space when you flip two coins, what would that be, you think? Well, that's just a listing of all the outcomes. So when we flip two coins, what are the possible outcomes? Well, you could have heads, heads. You could have heads, tails. You could have tails, heads. You could have tails, tails. We've done that one before, but in the probability realm, it's called the sample space. So it's just a listing of all the possible outcomes. All right? That's what I mean by sample space. Okay. All right, so yeah, let's just do some more probability computations here. And yeah, let's do the two coins one again. All right, so two coins are flipped. Number one, what's the possibility? What's the probability, I should say? What's the probability both are heads? Two coins flipped, probability both are heads. Well, again, we are talking about the the heads, 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 tails, tails, heads, tails, tails possibilities. So knowing those are the possibilities, what's the probability both are heads? Well, how many of them are both heads out of those possibilities? There's one of them that's both heads. So that's my top number out of how many? 1, 2, 3, 4. 1/4. Okay? So the probability of both heads is 1/4. Change that to a decimal, it'd be 0.25. The book will, go with the fraction, but just, make sure you understand there it is correlates to a decimal there, and what is 0.25 as a percent? 25%, wouldn't it? Okay? All right. Now, number two, I may also ask you there, how many, or what's the probability you get exactly 1 tails? What's the probability you get exactly 1 tails? Exactly 1 tails. Well, probability you get exactly 1 tails would be, well, how many of those have exactly 1 tails? That one? What about that one? Exactly 1 tails, isn't it? So those two have exactly 1 tails, don't they? This one doesn't count because it has 2 tails. I want the only ones that have exactly 2 tails, so it'd be 2 of them out of still 4, right? Which I bring this up because, yeah, you can reduce these just like you would a normal fraction. 2/4 reduces to be what? Be 1/2, wouldn't it? Reduce those by 2. So yeah, this too would be a probability of 1/2 or 50%. Okay? Not too bad, huh? All right, well, we'll also roll a die or dice. Okay, so let's roll a pair of dice. Okay, number 1 on it, let's say, what's the probability of getting a sum of 9? What is the probability of getting a sum of 9? Okay, well, probability of getting a sum of 9. How many ways can we get a sum of 9? Yeah, the best way, just go through here and list them. You can do. Now, on a pair of dice, we go up to how many? 6. We can only go up to 6. Each die has 1 through 6 on it. So, one possibility for getting a sum of 9 would be 3 and 6. And then flip that, reverse that, just like the heads and tails. That would be another one, 6 and 3. And then 4 and 5. Along with 5 and 4. So yeah, don't forget to reverse them, and I think that's about it, because 2, 7 would not be in that possibilities because you can only go up to 6. And 1 and 8, same thing. Okay, so there's 4 of them. So the probability that we get a sum of 9, which which brings up a little thought here that I had in the counting chapter. We talked about how many were there. Now we're talking probability, so what that changes is now we're talking a fraction, right? We're still counting how many there are, which there's 4, but we also want to divide that. What do we divide it by? How many possible outcomes there are? Total number of outcomes? Well, the one on top is how many successes there are. Now we want to know, if I listed all of them out, how many of them are there? Well, we did that too. I don't know that we wrote it all out, but we looked at least look in the table. There's a table in the book that has, it was we did started anyway in class, where you started with 1, 1, and then 1, 2, and 1, 3, 3, and so forth, all the way down to 1. How many were there? 36, wasn't there? Because you had six rows and 6 columns all together. If you go from 1, 1 all the way through 6, the last one would be 6, 6. So there's 36. There's 36 outcomes.
Can you not just do 9 times 4 and get that without having to do all that?
Well, it's 6 times 6. Yeah, 6 times 6. Because 6. What I'm saying is, it's 36, but it's 6 times. There's 6 possible for the first and 6 possible for the second. Okay? All right. Which is 36. All right. Which that reduces to be 1/9. Okay. Okay, so let's try another one of those. Number 2 on that.
So the top number is the number of successes. That's
How many ways that the top number is how many ways it could happen that you get a sum of 9. The successful ways of getting 9. And then the bottom's how many possible there are altogether. Let's do another. All right, so what is the probability both dice are odd? What is the probability both dice are odd? Well, we could have 1, 1. That would be odd, right? Then we'd have 1, 3. What else? 1, 5. What about 3, 1, 3, 3, 3, 5? What about 5, 1? Because again, 1, 5 and 5, 1 are different. It's like the first one is 1 here, the second one's 5. Here's the first one's 5, the second one's 1. So the order changes it up. All right, so that'd be 5, 3 and 5, 5. Think of any others? I believe that'd be it. So what's the probability? Both are odd. You tell me. What's the probability both are odd then? Well, how many successes? So it's always this. Let's write it. Successes over total. What have I got for that here? Well, here's the successes, right? 9. 9 of those. And then what's the total? Well, it's rolling a pair of dice. When you roll a pair of dice, how many total outcomes are there? 36. Yeah. So that's 6 by 6 table. If you listed them all out, you'd have 36 of them. 9 over 36 is the probability both are odd, which is reducible to 1/4. Reduced by 9. Okay? Yeah, fraction is preferred right here for now. We'll do some others with percents, but later on. Okay? All right. So, usually it's about listing. If you want to go ahead and list all 36 out, help you visualize it there, that's perfectly fine. Do that. Which that's what we're going to do on this next one anyway.